Hello, hello, hello. Welcome to another how-to video, this time in SolidWorks Electrical. I posted a previous video in which I showed how to create the scheme, the 2D representation of a part in our wiring diagram. I thought I'd complete sort of the manufacturing part process in this video with a line diagram and a 3D, not the 3D part, the 2D footprint. Now, the 3D part, I say not that. Um, SolidWorks Electrical has the ability that when we create a panel layout, a two-dimensional panel layout, it can actually export that directly to SolidWorks with 3D models, so you can see your panel in 3D. And then in SolidWorks, there's some cool wire routing capabilities that mesh with electrical. I've got to be honest, in my workflow, the types of machines I build, they're all one-off. That's I don't want to. I'm not disparaging the software when I say this. It's kind of a waste of my time. It's not enough benefit for the time spent to get all that stuff to work correctly in my world. 2D is good enough, so I stop at sort of the 2D panel layout. If you're doing like mass production, we're building this thing and we're going to build 100 of them. A 3D the 3D thing is awesome, and it's great for marketing and all kinds of stuff. It is an awesome feature. It's just a thing that I don't find a need for. So I'm going to go ahead and skip that part. Plus, I mean, I've never actually done it. I mean, I've played around with it, but it's hard to do a tutorial on a thing you've never done. But we need to. I'm going to start with. I mean, well, let's do the line diagram first. That's sort of the simpler version, or the simpler of the two things I want to sort of accomplish here. So I'm going to get out of the manufacturer part manager, and I'm going to go to the symbol manager. Line diagrams exist in in the symbol manager. If we go up, there should be one in black boxes. Yeah, these are line diagram symbols. If I click this, I didn't want to double click it. That was my mistake. I right click the properties in here. It's a black box symbol. Oh, maybe not. Anyway, in here we should have a line diagram symbol under type. So we're going to basically follow the same basic process, except we're going to be in our digital inputs because I was creating a digital input card. In fact, this is the one we created in the last video. I'm going to create a new, and here, instead of multi-wire is the schematic symbol. I'm going to scroll to line diagram. Again, now I also leave the drawing system as metric. I have tried to change it to inches and it sort of messes everything up from snapping and everything else. I leave it as metric, and I mentioned in the last video how we sort of get around that. But so I like to assign everything I create to my user objects, my title. Now in this case, I mentioned in the schematic, because it's reusable, that this should be a more generic name. Same is true here, but not quite as generic, because when we create this symbol, I like to throw an actual picture in there of the IO card. I like to do that, for clarity's sake, an actual, image. So therefore, it's not going to be as generic, because it's really going to only apply to cards that are at least recognizable by that picture. So less generic, but still somewhat generic, because 5069 16 point input, because at the scale that this picture is going to be used, um, we can get away, and I still have in another tab the manual, or I did. Did it close? It closed the pop-up. How dare you? This is the point, and notice they sort of give you one data sheet. Alan Bradley does, for 3 different cards. So this symbol that we're about to create, the wiring, or the line diagram symbol, can apply to all 3 of these cards. So that picture should work for all 3. They should be close enough that it doesn't sort of mess anybody up. Again, manufacturer, we can assign a manufacturer in this case because it's all Alan Bradley, that picture. We don't necessarily want to assign a reference, which would be down to the part number level, because again, it can apply to 3 different part numbers. Because of that, I'm just sort of going to leave it blank. Cross references, again, I do want cross references, same level probably, and connection points. That just means when we drop it in a drawing, it's going to show the red dots where the wires go. I like that. It doesn't, really mess anything up. It helps with snapping, all kinds of stuff. So those are sort of the settings to create. And again, we now have a blank here. I'm just going to double check that I set it to a line. I did set it to a line diagram. So in here, it's the same interface. It's a drawing interface, like an old school AutoCAD style drawing interface. But we're basically going to yeah, create, just a symbol. So the first thing here is probably, because these symbols aren't necessarily, we don't need to line them up on a line diagram as precisely as we do on a wiring diagram, a schematic, a scheme. So here I'm probably going to start with the attributes and get the text sizes and build my symbol around the text size. So again, I want the tag. The tag is the component mark, which would be in the case of like a circuit breaker CB502, whatever. That's a variable that's going to pull in that number. I probably want, again, manufacturer part. In this case, if you remember the last video, we had some other information here that we could have grabbed. But I'm going to grab the manufacturer, the reference. I'm going to grab all, because again, this is an I/O card, and when I put a PLC together, there's a chance that if I use just the base, that it'll only grab the PLC part number. I don't want to do that. I want to grab the actual card, and that's where all comes in. So there, what else did we need? User data. I like the description. I like having that. That's a little extra information. And then, of course, cross references. Where are you? Right here. Cross reference. Okay. We'll drop that text in. And again, we'll sort of build the symbol around the text, right? Of all this information I just grabbed, the tag is the most important. And I'm going to turn snap off for this. Moving text around snap gets kind of annoying. Grab all of these and the tag and change the alignment to center. Right, and I can drop these down here. Now the symbols in this one I always make smaller. Cross-reference I always make smaller. These I always make smaller. And we got to be quicker, got to be quicker than the software. So big tag, smaller manufacturer parts, and smaller description. So we're going to kind of work around the size of this text. And the way we're going to do this is we're just basically going to drop a rectangle in. And it doesn't really matter in this case. I'm going to turn my snap back on for the purposes of rectangling. It doesn't really matter. We're just going to, sort of draw a rectangle. And we can resize it and stuff later. We're going to put all this stuff now, tag, snap back off for moving. This stuff, generally speaking, I like to separate with lines. So again, we'll grab a line, and actually I should let's practice good principles. I should have dimensioned things properly. Let's go here. We're going to start at 0, 0. Let's be precise, and let's go at 0, because we don't want to go. I want to do the vertical first. Let's see if 20 is tall enough. We'll start there and sort of bring this in, and I can tell you that it's not going to be tall enough, but that might be tall enough for the image that we want to drop in. So let's go ahead and do that. Let's drop the image in. We want to, first, I need to remember, I don't think it'll let me first of all, we want to insert. If we attach, it doesn't actually display right. It just goes into sort of our database. We want to insert, and I do believe, yeah, I'm going to have to save it. So let's pop back out to Alan Bradley's website, and I'm going to swipe this image. Save image as. That's fine. And insert. Now we've got all this stuff. It's going to bring that in. Scale. We're going to specify the scale later, right? Insertion point. We're going to specify later. That's going to allow me to drop the image in and then sort of scale it to what I want. And I like kind of that size right there. I mean, completely arbitrary. That's just, it looks like what I like. So from here, I'm going to go over 10. Oop, I needed 20. Easy fix at another 10, 0, and then come back down at 0 comma minus 20. And then now I can do an absolute, go back to the origin 0, 0 because it's closing the box. Move the picture sort of in the middle of that. It's handy because it was a square picture. I think it said 1,000 by 1,000 pixels. Um, so there, now we've got an image in. Now we can sort of build. I like to enclose this in a box, and then enclose this in a sort of header box. And it's really at this point just drawing lines. So up here, I have no idea. Let's do at 0 comma 10 and see what happens. That's too tall, but that would probably work for the overall. So I'm going to leave it at 20 comma 0 and then come back at 0 comma minus 10. Come back. We're enclosed now. We're enclosed. So here, here. These are probably horribly aligned. They're not off by much, but you can tell these blue dots don't kind of line up. And again, it's a bit of a guessing game getting things, properly centered, because we can't really, I mean, if you're moving one attribute, you can, but there's not really a good construction method for these attributes to get them precisely where we want them. So I'm going to drop another line in and start there, and now just do at 20 comma 0. And really, um, outside of some alignment, I would play with that, get it right. But outside of some alignment, I'm going to drop the cross reference. I like it down in the lower right on just about everything. Going to leave it there. Then when it comes to editing the symbol as far as circuits and connection points and whatnot, we don't really do that in a line diagram symbol. Because line diagrams are going to be connected with, quote, cables, and cables don't really need connection points. Once we get a cable in, then we can sort of define where the individual wires inside it go. But we don't really need connection points. So really, as far as a 2D or a 2D, a line diagram symbol is concerned, this is finished. I'm going to Control S to save it. Again, it's a DWG, so we have to save. And if you forget, it will remind you when you close the tab. In order to make this work, we need a new wiring line diagram, right? And I can insert a symbol here. Now, usually on the wiring line diagram, I would not use this format. So let's be precise again. Title block, I want to replace. I do want it to be B without columns and just this drawing. If I had clicked all of them, it would have changed all of these other drawings, right? I want the columns in the other ones, but in a 2D or in a line diagram, I don't. So I'm going to insert a symbol. It automatically, because this is a line diagram that I told it this drawing is a line diagram, automatically filters out anything that's not a line diagram symbol. So you can see the only one I've got to choose is the one I just created. The connection outline was not created. That's new. That's new. Okay. Fine, fine. But we drop this in. We can associate it now with a part. In fact, we have an existing part, right? This here, this, I mean, we don't have much in this, we don't have much in this project, but this would be all the parts we have. And this symbol is the card I put in the last video, so we can select it so that these are now the same part. I'm saying this schematic symbol is this line diagram symbol. Okay. And I can hit OK now. Notice it pulled in all of that other information because we already defined it on the other symbol. And I'm going to have to double check. Let's open this up. Symbol, I want to see, I've never been yelled at before about a connection edit symbol. I mean, there's nothing here to actually do that with. I don't know what they were asking for. That's odd. New connection point? No, I can't even do that. There's nothing. Okay. I'm gonna assume, I mean, it came in, it looks like it's working. If I were to draw a cable now, like I said, line diagrams are connected with cables. So if I draw a cable, it should let me. I don't think it'll let. Yeah, it will. So it connected it. The red dot means it is connected now to this part. And that's how, by the way, once we get more, line diagram symbols in, they're all connected by via cable. Or in the case of a PLC, um, it would be, and actually this cross reference isn't going to work there now that I think about it, but we can change later. As we get more cards, for PLCs, I just, smash them together like this, right? I'm just pasting. I just smash them together because there's no cable, right? If this were, say, an Ethernet line diagram, and that's the most common thing that I use line diagrams for, is sort of the Ethernet layout, because we can also add attributes for IP addresses and things and have those automatically populate. Then we would want to connect everything with a cable, because we're then actually showing actual Ethernet cables. Or if we have a lot of field I/O with sort of M12 connectors, right? We can use M12 cables. The cool part about cables is those are purchased parts. We need to buy them from somebody. And if we have a line diagram showing all of our like prox cables going out to proximity sensors, then we can also, they show up on the BOM. Cables are a bill of material item. So it's important to sort of get that right. I wouldn't say it's absolutely mission critical, but it's important to get it right so that we have, a complete bill of materials that we can just order. So, but this is, I mean, that's it. That's a line diagram symbol right there. They are very handy to show sort of the sort of a big overview of the entire system without getting into the weeds of the wiring. Right, we'd show how things are connected, how it's laid out logically, stuff like that. So last step, that is the symbol. Last step, I'm going to double back to library and the manufacturer part, and I want to associate that symbol with the part. I don't want to associate the symbol with the part. I want to associate the part with the symbol. It's a subtle difference. In this case, this part will always use that line diagram symbol. But that line diagram symbol, like I said, when we created it, will not always be this part. There's two other part numbers it could possibly be. So this association is fine. The other association, not so much. Then to call this a complete part, sort of the last thing I would do is this 2D footprint. So again, I got to get out of the manufacturer's part number, and this is going to require Allen Bradley. And under drawings, two-dimensional drawing DXF is exactly what we want. I'm just going to download that. And again, I mean, as far as I can tell anyway, I'm not actually logged in. So you should not need necessarily an account to get to this stuff. But even if you do, this level of access to Allen Bradley doesn't actually require licensing. There are certain parts of their website where you do need to log in because you have to have an active license. So we've got DXF files, we've got DWG files. And I'm going to come in here back to SolidWorks. I'm going to. All right, and through the magic of video editing, you guys have no idea that I just spent like 20 minutes fumbling around trying to find a simple open command. Except that maybe I shouldn't have mentioned that. Sorry. So I guess you do know. Anyway, because I'm apparently too silly to check the file menu and click open, and we should be able to open the drawing directly from Allen Bradley now. We're going to use this for our 2D footprint, and I like to do it this way again because if we just look in the PDF manuals, the dimensions they give you are going to be this 22 millimeters, which is the primary width of this card. However, our 2D cabinet layout is going to put a bounding box around our symbol, and it's going to catch everything. So the bounding box is going to go all the way out to the end of this tab, which is 25.56, right? So the 22 isn't good enough. Also, if we look at the side view, the height also, where is the height dimension called out here? Yeah, I don't know what they would actually call it in the PDF, but it leaves out the locking tab thing that sticks up, right? Our bounding box is going to include that. So it's best to just sort of grab the actual DXF, actual drawing, if you can, from the manufacturer, rather than go off like PDF dimensions, because we want to be accurate with the bounding box. So I'm just going to grab this guy. I'm going to copy, and actually I probably should have created a new drawing first, but library. We're going to go to 2D Footprints Manager this time. I've already created it. Part of that 20 minutes I spent fumbling around. I have, at the time of filming this, no idea where I'm actually going to splice this into that video. Um, because I mean, I kind of hate editing. That's why I don't. So, but in this case, I didn't want to, tank an entire, hour-long video. So we've got the drawing already. I can just literally paste. Now, this is, it doesn't really matter where we drop it for now. I'll move it later. It takes it a second sometimes to really think about it. There's a lot of detail in here. This now is 1 millimeter, right? Literally, that dimension updated. It is 1 millimeter, and it did that because it thinks what we pasted in was in standard. It's a conversion problem, so we don't want it to be this size. Like, for instance, if I drop an attribute in here with our standard tag, like, look at how huge that is. We don't want that. We want to scale this guy. We can do that pretty easily. We have a modify and we have a scale right here. So since we know it's a conversion problem, I'm going to grab everything that's not a dimension. In fact, the dimensions are going to get deleted. They just came in because of how I copy and pasted. Everything that's not a dimension, I'm going to scale it. I might, it doesn't matter what you scale it about at this point, because I'm going to move it in a minute anyway. Scale it to, we're going to enlarge, and we know it was a conversion problem. We're going to scale it up 25.4 times. We should now, I'm going to delete these. We should now be accurate. That should have been what? Something like 25.56 millimeters, tab to tab. Let's, we have dimensions. Where are you? Under the draw tab, dimensions. And let's kill my snap because it's stopping me from getting the parts I want here to here. 25.55. I'm kind of okay with that, right? We're off by 0.01 millimeters. So now that's kind of what we need to define in order to get this guy inserted into a drawing. Now, I like to insert these on purpose somewhere. So the red dot here is the green is the origin. How about I start there? Change of thought mid word even. The green is 0, 0. The red is not necessarily 0, 0. The red circle, that is where the symbol will be inserted. Like, where on our cursor will the symbol attach when we go to put it in a drawing. We can move that around under edit symbol and insertion point, right? We can move it around. And on 2D footprints, not necessarily all of them, but quite a few, I recommend aiming that insertion point somewhere in the middle if you can, because these things snap to a DIN rail, right? That's like the whole point. They snap to a DIN rail, right? This is a DIN rail mount. And so when we insert them, if we put the insertion point in the middle somewhere, we could snap it on our cabinet layout to the center of the DIN rail. Comes in handy. If we leave it down here in the corner, we're just kind of guessing at where the middle is, right? So, and actually this line looks like, this isn't honestly this isn't a truly precise task, but it looks like somewhere just north of whatever this is. That's part of the interface that connects modules together. So something just north of that. And I mean, I would even be happy grabbing the insertion point right at that. And I want to, so we needed to account for this distance in the width. That's why we're going through this whole exercise. This width doesn't really matter. We can lose that because those pins they're spring loaded. They kind of smush together anyway. So when we put it together, this width doesn't really matter. It matters as far as our bounding box is concerned for overall width of the symbol, but it does not really matter when we drop it in the drawing. So I would even be happy putting the insertion point right here at this corner, even though if again, I'm guessing, and if I just kind of try to run across straight, it's slightly above that. I think right at that corner is fine. Um, but this is, so we'll grab the insertion point and snap it. I'm going to put it right at that corner. So notice the red circle moved. The green is still down here because the green is 0, 0. That's 0, 0 for the drawing, but the red circle can literally go anywhere. And we could do that in other symbols too. In the previous videos, you could move the insertion points. But for most of the other symbols, it was okay to just leave the insertion point at 0 where we started the symbol. So now I do want to get an accurate dimension off of these for the sake of the bounding box. And that looks like the widest point. So I'm going to draw dimension. I want that corner. And the widest point is going to be these tabs out here that sort of lock cards together. And okay, so it's going to give me 1 millimeter. That's not awesome. Let's do it here. Let's do it in this drawing since we scaled it up. Draw. Dimensions, again, that corner. The widest point to widest point is what we want, which is going to be somewhere out here. And again, I mean, there's a slight angle. You can see so 27.53 overall. That's important because that is going to go into library, the manufacturer part manager. We're going to find that card that we created, the part right here, and that's now our width. And I forgot what it was already, 57.75. I'll start there and change it in a second. Close, go back. Let's do it again. That's going to be our width so that it scales properly when we drop it into a drawing. That scaling will happen automatically as long as we press 27.53, 53, 53, 53. Manufacturer part 53, 53, 57.53. Okay, now we need to go back and do the same thing for the height. The scaling happens automatically. This will be sized appropriately to our drawing, regardless of scale. We set the scale in the drawing and SolidWorks figures it out. It says this should be 57 millimeters wide and we'll scale it appropriately. So it's important to have those sort of as accurate as we can anyway. I mean, super precise doesn't really matter. There's obviously a point of diminishing returns, but let's do a linear dimension. We need the height, and we need the big height. So again, I'm not going to be able to snap to the top of that curve, but this will be close enough. And down here, I can probably get one of these flats, which is the low point, which is fine. And 144. 144 even is what we're going to go with. Library, manufacturer, part. And this is, again, I recommend doing it off of the drawing the way I'm showing it right here. 144 before I forget. 144. I recommend doing it off of the drawing before I forget, or off of the drawing rather than off of a PDF, because the PDF often doesn't account for those little things like locking tabs or the pins that stick out the side or whatever, but SolidWorks Electrical does. It considers that. Now for the depth is really, the depth helps in two ways. So it's used for the 3D model. If we were to build our cabinet and export a 3D SolidWorks model of it, it uses the depth to scale those parts. And it's kind of cool when it does that. So it needs all three dimensions if we're doing 3D. For 2D, we only need the two. I do like to put a depth in here because then I can look at the parts that are going into my cabinet and make sure I bought a deep enough cabinet. I have run into where I've bought an 8-inch deep cabinet, but I have a 10-inch motor drive going in it, right? So putting a depth in here is good for that, but we don't need to be very accurate there when I can just look at this and pull the dimension, and I'm happy with that. So 105.42 is what I'm going to use. That's the dimension they give. Actually, I'll use that one because it's worse. 109.09, right? I don't have to be super precise. I don't have to get the lowest of the low and the highest of the high. In fact, that 109.09 looks like it already did it for me, but I don't have to be super precise on the depth. It's because I don't use the 3D capability, I'm just looking for like a sanity check to make sure the cabinet I'm trying to put this in is deep enough. So 109.09. Try to remember that for more than 30 seconds. 109.09, and it didn't remember my height? How dare you? Okay, why didn't it remember? It remembered that, right? Yes, okay. So I guess I'll go back in and measure the height again. I don't remember, I didn't remember switching tabs. I definitely don't remember between all that talking too. So again here, and we're missing a little, right? If I go straight horizontal, we're missing a little, but it doesn't have to be absolutely perfect. We're just looking to get the scale right, right? And it'll be close. It'll be off by a little. All right, 144. Don't know why you didn't save it, but do it again. PLC IO and 144. Enter, just in case. Okay. So that's good. Now, this is, I mean, mostly done, but we need some attributes, right? We need some attributes, so I'm going to do the same exact things we've done before. The tag, obviously, tag is the most important. Manufacturer part, again, I'm going to grab all, the all version, and then user data. Usually I leave the description off, but I kind of do want the cross-reference. On a 2D view, well, I suppose we could put it on there. Usually I do leave it off, but I guess just for completeness, we'll throw it on. So we get, again, all of those all at once in a lump, and then it's up to us to sort of move them around. So cross-reference. Now, text does not scale. As this thing, this symbol gets dropped into a 2D drawing, the text does not scale. So this thing, I mean, realistically could, if we're printing it on, like 36-foot wide paper, could be 10 feet wide. The text will still appear relatively the same size. Or I should say, I guess technically that is scaling, but the text is going to show up when we put this in a drawing exactly the way that it shows up here. So we want to get the sizes sort of proportional to this symbol, right? I'm okay with the size of the cross reference. I like those smaller. I'm probably okay with the size. I want the tag out of there. I'm probably okay with the size of these guys. And snap has got to go. When you're playing with text, I find snap kind of gets in the way. All right, I'm kind of okay with the relative size of these guys. Oops, don't do that. That was an up arrow. Up arrow apparently goes to the next snap point. Never done that before. So this I do want a little bigger probably. Right? I like the tag to be nice and prominent. That's going to be the big feature. Now, and are we lined up anywhere near close? No. Here. Somewhere in that neighborhood. It's always tough because the variables start with a hashtag, which is slanty. It's, sort of by definition hard to line up something that's slanty. So we also need to think when we're doing these about how these symbols sort of go together in our drawing, which is hard to do sometimes because, in this series I haven't done a drawing yet, right? But we need to consider the fact that this is the width of this module, right? And if that part number gets long and I put this here and that part number gets long and I start to drop another module, the text is going to start to overlap because remember, these are variables, right? It's going to populate from the database whatever we set them to when we put it in. So these could be really long, and then I throw another card here where the text starts is going to overlap. So because this is so narrow, these newer IO cards on Allen Bradley are so narrow, I like to rotate these. And I don't remember if I need 90 or negative 90. I just plain don't remember, but we'll try it. 90 is what I wanted, but it blew everything up, so we'll redo. That's fine. We can fix it. That's going to be the description. That's going to be the part number. That's going to be the manufacturer. You can get them kind of, sort of lined back up. I like to rotate them if the part, again, is going to be is super narrow, and these are. That way, the text will go vertical rather than we'll sort of line it up with the center of the thing. And that's it. That's the symbol. So again, this is a drawing. We need to control S it. We need to save it. Okay, we need to save it. We'll close that. Now we don't need that anymore. I don't need to save change. I didn't make any changes. And then I'm going to go into my manufacturer part and I'm going to associate that footprint with that card. Okay, we're going to associate the footprint, 2D footprint. We're going to find it, and it's that card. Okay, and close. And now forever, that part now has a scheme, a line diagram, and a 2D footprint assigned to it forever, so we can reuse it and never have to do the stuff we just did in these last couple of videos ever again. Right, that card is in here in our database now forever. There might be some stuff we want to clean up, like crap, I didn't align the set right, but that's simple stuff. We never have to worry about it again. And that's kind of the cool part about the database driven. Once you get things sort of set up and you're rolling for, I don't know, 6 months, a year, and you've got it set up the way you like it, it gets really, really, really fast to knock out schematics in this software. And that's sort of why, one of the reasons I like it so much. But to do a 2D now, to do a 2D cabinet layout, I'm not going to show the full cabinet layout, all the ins and outs, but I do want to show what that symbol looks like when we drop one in. So to do that, basically the first thing we need to do is find the right place. Process. It's under process, a 2D cabinet layout. It is not an option over here, right, to just add a page for a layout. We have to do it here. It's treated separately. And I have not talked about locations, but it is going to want to create a layout per location. We need to be kind of tricky with our locations, and I'll get into that in future videos when I do a more in-depth layout maybe. Locations are ways the database can kind of label, literally physically, where things are. They can be helpful to use. Again, if we're handing this to somebody that's untrained, he can look at the location list and tell physically where he's looking for certain things that he sees on our drawings. In the case of cabinet layouts, it's also important because I'm only allowed one layout per location. And that's a problem sometimes. For instance, if I want to do a layout for like buttons that I have to cut holes in the door of the cabinet for, and then the back plane, right? I only get one layout, so the back plane's the important part, but then I don't have anything I can do the whole layout for the buttons with. So in that case, I might actually create a location that says main cabinet back plane, main cabinet box, and separate the two so that I can get two different layouts. It's tricks, and I will do another video in the future on it, I think, because there's some tricks and pitfalls, but that's sort of one of the drawbacks. You only get one 2D layout per location. So I'm going to just hit OK, and I'm going to get two because two were checked. So there's one associated with the project, one associated with location one, which is the main electrical closet, is what it was called. Okay. So these are all the parts, a list over here on the left, all the parts that are in our project so far, which is kind of cool. If they have 2D layouts like this, circuit breaker had one already. That's what this symbol means. That's 2D layout. I can check that, and it'll let me insert it. Ooh, that's going to become in tiny. Hopefully we can scale it later. I'm going to insert it. That's really tiny, but if I go in, see it pulled in the CB502, and there's a 2D footprint. I'll bet it came in so small because this part does not have the height and the width defined. But this fuse and this power supply don't have footprints, so it doesn't offer me the expansion. But this part does because we just created it. So I can check that and bring it in. And this one comes in correctly. Well, it's still little. It's still little, but notice it populated with the attributes we put in. They're angled so we don't overlap. We've got our cross-reference. It tells us, where the other parts are or where the other instances of this thing is. And then scaling is going to pop up. If I go back to the drawing, scaling, let's go to properties. It should be in the properties, scale 1 to 10. Need to play with the scale because again, we're dealing with 11 by 17 paper, and I mean most commonly in my world I deal with like 24-inch cabinets. So you need to play with the scale just to get it to look right. I do recommend with a cabinet layout, and I'll mention this again in future videos, I do recommend doing the layout as you see it, sort of vertically. However, with a rectangular cabinet, it can it can be made bigger doing it sideways. Do the layout vertically and then rotate it and scale it up. That works out, in my opinion, in my experience, much better than trying to lay it out sideways. So I'm going to delete that circuit breaker because it's bugging me. But that's my sort of advice on that topic without getting into the weeds too far. Is design just as you see it. Lay it out vertically, and then if you want to rotate it because you can make it bigger, take more advantage of the fact that this is rectangular. Rotate it and scale it up after the layout is finished. It's just way easier to lay things out in this orientation. So anyway, changing scale, we can demonstrate. So properties on that. Let's drop it down. Let's double it. 1 to 5. Right? 1 to 5. That got bigger. I think it got bigger. It looks like it got bigger. Let's do it again. Let's go nuts. Let's just go 1 to 1. 1. Notice the title block is B with scale. Our normal scheme doesn't have scale. And notice as we go, again, the letters are staying where they belong. Or the relative size at where they belong. So let's update just in case. Yeah, the letters are scaling with it. So basically, when we create this 2D footprint, you basically want to create your labeling. We don't really have control, and honestly, it bugs me. As nerdy as I am, we don't really have control over what the final text height of this is on this drawing. So as things scale up and down based on their actual size, the text from part to part is going to have all kinds of different font sizes. That bothers me, but I got to live with it because we don't really have that level of fine control to make them match, right? The size is driven by the symbol. So it's a thing I got to live with. But that is the creation of a 2D footprint, right? Same process for every part. I will admit, I do not always go out and grab the CAD. If there is something fairly simple, for instance, a power supply, most power supplies don't have a lot of things protruding that are going to genuinely affect the size, like the way that these tabs affect the overall size and how this scales. Power supplies are generally, from the top anyway, really rectangles. There's not much sticking out. So those I usually cheat, and I'll create a 2D footprint that is a rectangle, that might show some circles for the screw terminals, and then throw the attributes in and call it a day. So it just depends on. At the end of the day, accuracy is key. Getting as accurate as we can, again, without going nuts, because things like losing that little bit of height, right? This isn't going to be perfectly accurate, but accuracy is key in whatever we can do to properly represent the parts. So again, hopefully that was informative. Hopefully it was at least mildly entertaining as I rambled about nerd stuff in SolidWorks Electrical. Hopefully I find a good place to splice this portion of the video in and make it not look too ridiculous. So again, thank you for watching. I look forward to seeing you in the next one.